Alright, so let's take a look at the most missed questions from multiple choice set 3, big theorems, numbers 1 through 8. So number 1 here was one of the commonly missed ones. This one asks specifically about the intermediate value theorem and what is guaranteed. So first thing we need is a closed interval that's continuous. Alright, we've got both of those, and it's from -3 to 6. So what intermediate value theorem guarantees is that as I go from the x value -3, at which the function is down here at -1, alright, over to the x value of 6, where the function is up here at 3. What I know is I'm going to hit every single value from that -1 up to that 3 at some point at least once. Now, I could go above, I could hit it multiple times, right? But every single value as I go through that is going to get touched somewhere on that graph. All right, so when I look at this, the first conclusion is f of 0 equals 0. All right, we can't say anything about that with intermediate value theorem. All right, the next one says f prime of c, so the derivative of c. All right, so the derivative of c sounds more like mean value theorem rather than intermediate value theorem. All right, this one is out as well. All right, next one says -1 is less than or equal to f of x is less than or equal to 3 for all values between -3 and 6. All right, as we just mentioned, you can definitely go above or below those values. It's just saying you do hit every value in between at least once. All right, so that's out as well. The next one says f of c equals 1 for at least one value of c between -3 and -6. All right, -3 to -6, so we have the right, left, and right bounds. All right, it's a value 1, which is between the two outputs we had. So that is something that can be guaranteed by intermediate value theorem. And then the last one says f of c equals 0 for at least one value of c between -1 and 3. All right, so -1 and 3, we'd be in a little section in the middle here. All right, and we can't say for sure because it might hit that value outside of that little section somewhere between -3 and 6. All right, so our correct answer on this one is D. All right, now there are two more that hung people up a little bit. The next one is number 7. So number 7 says, let f be a function defined by f of x equals x plus ln of x. What is the value of c for which the instantaneous rate of change of f at x equals c is the same as the average rate of change? All right, so this is a rock equals I rock. All right, so when I look at average rate of change, we're going to plug 4 in. All right, top and bottom. So we're going to lean on the calculator for this one. All right, so I've got the function in y1 on my calculator. So I'm going to go back to my home screen on the calculator. I'm going to clear things out just so I'm working from a fresh place. And I want to find over the interval from 1 to 4. So what I need to find is f of 4 minus f of 1 over 4 minus 1. This will give me the average rate of change. All right, so on my calculator, I'm going to do alpha trace, choose number 1. I'm going to plug 4 into that, minus alpha trace. I'm going to choose 1. I'm going to plug 1 into that. I'm going to hit enter, and then divide by 3. All right, so that gives me an average rate of change of 1.462. All right, and then on the other side, I need instantaneous rate of change. So I'm going to take the derivative of f, get f prime, which is going to be 1 plus 1 over x. All right, so I'm going to go to my calculator. I'm going to store this in a, the last number. So that's in there now. All right. I'm going to go to y equals. I'm going to go ahead and, on the second one, I'm just going to type the derivative in directly because I found it fairly easy. I could also let the calculator do that work for me, but I don't need to. And then here, I'm going to go ahead and put a in for a constant because I want to find out when those two are equal. I'm going to go back up and turn off the original function so we don't have to worry about that. For window on this one, I'm going 1 to 4. So my x values are 1 up to 4. And for the y values, I'm curious about when this equals 1.462. So I'm just going to go like a 0 to 3. That should give me more than enough room to see the intersection points. So I'll hit graph. And we've got our first curve coming in, our constant coming in. We have one intersection point there, so I'm going to go second trace, intersect, which is number 5. And there's only one, so I'm just going to hit enter 3 times. All right, and that gives me a 2.164. All right, so x equals 2.164, which is choice C. All right, and that would be our one spot that satisfies, in this case, the mean value theorem, MVT. All right, and then the last question that people had issues with is a fundamental theorem of calculus problem. So this is the derivative of an integral, and what we've got to notice is we've got this bound change up there. All right, so normally if that's just an x up there, we're just going to rewrite this thing with an x. This time it's an x cubed, so we're going to rewrite it, and instead of a t, we're going to put an x cubed in, and then we're going to multiply by the derivative of that, the 3x squared. All right, so if I clean that up a little bit, I've got 3x squared ln x to the 6th plus 1. All right, so 3x squared ln x to the 6th plus 1. That looks like E is the correct choice. All right, so we choose E on this one. And that's all we need to do, because the integral would give us the antiderivative. Then we take the derivative of that, which gives us the function we started with right back. All right, so we're never actually taking the derivative of the ln, because we take the antiderivative of it first, and then the derivative of the antiderivative. All right, so those were the 3 most missed questions. Hope that helps. See you tomorrow at the Q&A session.